Hello and welcome to our lesson on graphing linear inequalities. So inequalities first, let me leave the note sheet for a second here. We hopefully remember the difference between an equation and an inequality, because everything so far in this module we've been dealing with have been linear equations. So in this last section, we're going to be looking at linear inequalities. So equations, we know, have equal signs in them. And inequalities, if we recall, will have a greater than, less than, greater than equal to, or less than or equal to symbol. So when you solve a typical equation with one variable in it, let's say you're solving 2x plus 1 equals 5, we subtract the 1 to make 2x equal 4, we divide the 2 to make x equal 2, and we see the one distinct solution. Now if we solved something similar to x plus 1, but let's say it was an inequality, so let's say it was greater than 5, well, the steps are the same. We still subtract the 1 to get 4, and we still divide 2 to get 2, but instead of one distinct solution, one value of x that could be plugged back in to make that equation of true, when we're saying x is greater than 2, that's a whole interval of x values. There's a whole, like an infinite number of numbers that we could plug in for x to make that inequality true. So the same concept is going to occur when we're dealing with linear equations versus linear inequalities. So when we have a linear equation, for example, maybe we have something like y equals 2x plus 1. Okay, instead of 2x plus 1 equal to 5, we have it equal to y. Well, we know that this equation still has solutions, and in fact we can find an infinite number of them as well, but they're distinct, right? If I plug in 2, for instance, 2 times 2 would be 4 plus 1 would be 5. That is a distinct solution for that equation. Or if I plug in 0, 2 times 0 would be 0 plus 1 would be 1. Or if I plugged in, I don't know, negative 2. 2 times negative 2 would be negative 4, plus 1 would be negative 3. I can pick any x value I want, plug it in there, get a y value, but what I'm going to get is a list of distinct solutions. And when we graph these, we plot these points, plot these solutions, 2, 5, and 0, 1, and negative 2, negative 3, we end up connecting those points and creating the line that represents all of those solutions. Okay? Now when we're graphing a linear inequality, instead of something like y equal to 2x plus 1, if we had y greater than 2x plus 1, then what happens? Well, let me show you in Desmos, and then hopefully it will make a little bit of sense. Okay, so again, if we graphed, let's just confirm here what we did, 2x minus 1, we see all of the points on that line connected, and all of the points on that line are the solutions to that equation. Well, if we change this to, let's go with greater than or equal to. Well, greater than or equal to still has the equal to part. So notice the line is the same. Okay, and just so you can see it, if I put y equals 2x minus 1. It's the same exact line, okay? So that's there, but notice now we have this shading happening. That's because not only are the points on the line solutions, but now all of the points that are above that line are solutions as well. So we knew that, and I'm going to compare this to equal to for a second here, okay? So if it's equal to, then just like the equation version, all of these points are solutions. All the points on the line are solutions, but now all the points above the line. So for instance, if we look at this point up here, I'm just going to pick a point in the shaded area like negative 5, 5. If I plug negative 5 in for x and positive 5 in for y, I would have 5 greater than or equal to negative 10 plus 1, and 5 is definitely greater than or equal to negative 9. And so we're going to get this whole region of solutions instead of just the points on the line. It's the points on and above the line that make it true. Now watch what happens when I take the equal sign away. If I take the equal sign away, it makes that a dashed or dotted line, which means we're no longer equal. That means the points that are on the line are no longer solutions, but since it's greater, then all of the points above still are. So we're still shading above that line. And again, if we go to, let's say, less than, we have a dotted line. The points on the line are not solutions, but now all of the points below the line are solutions. And if it's less than or equal, we're back to a solid line. So the points on the line are solutions, and the points below the line are solutions. Okay, so just like with basic equations and inequalities, instead of just distinct solutions, we have this whole range of solutions that we want to include. So back to our note sheet here. When we're graphing a linear equation, right, where we have that equal sign, then all of the points on the line are the solutions to the equations. Okay, for linear equations, all points on the line are the solutions. Now, if it's a greater than or equal to, well, equal to means all the points on the line are still solutions, but greater than means all the points above are solutions as well. So if it's greater than or equal to, then all the points on and above the line are solutions. So to capture all of those solutions after we graph, which will be the same way we graphed before, using M, using B, or making a table of values, is just after we graph, we want to make sure that we shade above the line to capture all of the solutions, which we will call the solution region for our graph. Okay. Now, if we have greater than, that means we took away the equal. That means only the points above the line are going to be solutions. The points on the line are no longer solutions. So we will still be shading above our line to capture our solution region, but when we graph the line, we're going to use a dashed or dotted line because the points that are on the line are no longer solutions. They're going to make the thing equal, and we want it to be greater in this particular case. So we use a dashed line to exclude those points from the solution region. Now, if we have less than or equal to means all the points on the line are solutions. Less than means all the points on and below the line are solutions. And so we're going to shade below the line to capture the solution region. Now, if it's less than without the equal to, then only the points below the line are solutions. And so we will still shade below the line, but when we graph the line, we're going to use a dashed or dotted line to exclude the points on the line from the solution region. Because we don't want to be equal, we just want to be less. Okay? So we're going to graph the same way, and then decide if we have a dotted or solid line, and decide if we have to shade above or below. So looking at example 1, let's see if we can put all this together. We have a slope of 1/3, m equals 1/3. That's telling me that I'm rising 1 and running 3 to get from one point to the next. So that's going to go up 1 and right 3 from one point to the next. And the one point we're going to start with is B. So if B, our y-intercept, is -4, that's where we begin. Begin on the y-axis at 4. Okay, so we're going to start at -4, move up 1, right 3 from there to make another point. And then because our symbol is a greater than symbol, that tells me to use a dashed line because we're not equal. And it tells me that because it's greater, we want to shade above our line. Okay, so all that information picked out of that inequality there. So we have -4 on the y-axis is where we begin this graph. The slope is 1/3, so I'm going to rise 1, run 3 to make another point. And then I'm going to connect those with a dashed, sorry about that. I'm going to connect these with a dashed line. And so right now I haven't captured any solutions because those points on the line are not solutions to this inequality. The solutions are all the points that are above that line. Dashed line, shade above. And so everything up here is in my solution region. So it's the only way to capture all the solutions to a linear inequality. It's to graph and then shade the solution region. So when we shade that, what we're saying is any point that's up there above that line is going to make that inequality true. So for instance, and just so you can see this, I'm going to pick a test point. Pick a point that's in that region. So like whatever point you want. Maybe I'm going to pick this point up here. It's clearly in the solution region, right? So I'm going to pick 0, 10. It's in the solution region. So if I put 10 in for y and I put 0 in for x, I should get a true statement. Well, this ends up being 10 is greater than -4, which is absolutely true. So that should have been part of my shaded area. And the opposite will happen if you pick something over here that's not in your solution region. So for example, 5, -5, not in the solution region. That should make a false statement when you plug it in. So if you put -5 in, greater than 1/3 times 5 minus 4, -5 would be greater than 5/3 minus 4, and is it 5/3 minus 4? Yeah, 5/3 minus 4 is, I don't know, let's see, 4 over 1. I'd have to get common denominators. I should have picked a better number. So if I have 5/3 and I subtract 12/3, I get -7/3. That's like -2 point something. Well, that's definitely going to be greater than -5. So this one ends up being false, which is exactly what we want because that one was not in our solution region. Okay, that makes sense. Sorry about that fraction work. All right, and then we have Desmos to use to confirm our work if we wanted to. Okay, so let's try this again. Hope I didn't delete anything there. Let's try the next one. So we have here y less than or equal to -2/5. So this one doesn't have a number out here for b, which means we're going to begin on the y-axis at the origin. So begin on the y-axis at the origin, so I'm going to make that point. And then my slope is a -2/5, so that tells me from that point that I just made at the origin, I'm going to go down 2 and then right 5 to get to my next point. So from here, down 2, right 5, and make another point. Now when I connect them, I got to look at my symbol, which is a less than or equal to symbol. That is telling me to make a solid line. That equal to means all the points on the line are solutions, and because it's less than, it's telling me to shade below. So I'm going to connect these 2 points with a solid line, and that's pretty awful. Let's try that again. That's a little better. We're going to connect those with a solid line, and all of the points below are also going to be in the solution region. Okay, so we're calling this the solution region. And again, if you weren't sure, you pick a test point. So pick something that's clearly in there, whatever point you want. So I'm going to go with -5, -5. If I plug that in, I would have -5 less than or equal to -2/5 times -5, and that would be -5 less than or equal to +2. -5 is definitely less than +2. The true statement confirms that I shaded it in the right region. Okay, that was a test point, just to make sure. And again, you do have Desmos that can confirm this picture as well. All right, one for you to try. If you're feeling confident, give it a shot. If not, then let's do this one together as well. So in this case, I can see b is -1. So that's telling me begin on the y-axis with a point at -1. And this one is showing me my slope is 3. Now 3 as a fraction is 3 over 1. So that's telling me to get from that point that I just made to my next point, I can go up 3 and right 1 and make my next point. And, okay, I thought I messed that last one up. So from here, I'm going to go up 1, 2, 3, right 1, make another point. And now I look at my symbol, which is a greater than symbol. That symbol tells me that I'm not equal, so I'm going to make a dashed line. And because it's greater than, then I need to shade above my line. So I'm going to make a dashed line that goes through these points, because the points on this line are not part of the solution region. And then I want to shade above, because that's where all the points in my solution region are at. Okay, all those points up there. And if you want to test one of them, And you don't have to do a test point. I just like to. So let me pick, how about this guy? Negative 5, 5. If I put 5 in for y, it should be greater than 3 times negative 5 for x, minus 1. 5 is definitely bigger than negative 16, so that true statement confirms I'm in the right area. Okay? And I've got 2 left here, and these are our special cases, when we have a variable missing. So how do we graph when we have a variable missing? Well, this one isn't too bad. I could say this is y less than 0x plus 4. It just means we are going to cross the y-axis at 4, and our slope is 0. So we're not going to rise from one point to the next. We're just going to run. So I'm going to begin on my y-axis at 4, and then if I don't rise, if I just run, I can see what's forming here is a horizontal line. And because this symbol is a less than without the equal to, I'm going to make a dashed line. And I want to shade below that dashed line. So if I make my dashed horizontal line through those points and shade below, this would be all the y values, all the points that have y values less than 4. Okay? And again, you could pick something in that region. It's going to have a y value that's less than 4. So when it's the y and a number, then it's a horizontal line here. It's a little harder to read because we don't have an m and b situation. We don't have a y in the picture at all. But if you remember, think about a table of values. Okay, this is telling you that no matter what you try to input for y, x is going to be fixed at 3. So 1 or 3 or 0 or whatever you want to put over here, okay? All of your x values will be 3. So think about plotting a point at 3, 1, and at 3, 0, and at 3, negative 3. No matter where you are, if x is 3, then you're creating a vertical line this time. And vertical line, so this is a vertical line. And this one was our horizontal line. Oops, can't spell. I mean, I can, but yeah. Okay, so this one has the greater than or equal to, which is telling me to make a solid line, and it's telling me to shade. This is the tricky one here, okay? So I'm going to make a solid, use my cheat tool. I'm going to make a solid line through these points, and normally we're looking to shade above or below. Well, we can't be above or below a vertical line, but we want to be greater than. Okay, so look at the symbol and look at which way it's pointing. Where are we? Greater than 3. So greater than points this way, so we want to shade everything that is over in this area. Oh, the shading looks so much better with a highlighter. Why didn't I do that on all of them? I don't know. You get the picture, though. Okay? So that is the area of our graph. That is the solution region. That is the place where all of the coordinates are going to have x values that are greater than or equal to 3. That would be the points on that line and all the points left of that line. Okay? So we'll do more with linear inequalities in another module, but for now I think you have enough. This is just to kind of reinforce the graphing concept. So you've got enough to get going on your practice, but as always, if you need some extra help, then just reach out. All right, guys.